welcome you to my lecture today. Of course, today uh, we actually going to start a new chapter. But before I go into today's lecture, I basically want to make some announcements because I know some students don't check announcement section on Canvas. And this has to do with midterm one information. So I want to say the midterm one exam will be written online, just like the way I put that in the syllabus. The exam has already been uploaded, except that you are not going to have access until 6 p.m. on Friday. Now, uh, the exam is going to be open between 6 p.m. on the 23rd Friday to Saturday 11:59 p.m., which means you have more than 24 hours, except that when you click to start, you can only spend 1 hour 30 minutes, because the moment you click on start, okay, your time is going to be running out. You can choose to, you know, start at any time within the stipulated window. I'm going to say this again. I actually did that because I know you guys are having some other courses, and there's a lot of activity going on in the summer, and that was why I became so flexible and trying to make the exam to go from 6 p.m. On the 23rd Friday to Saturday 11:59 p.m. When I say 11:59 p.m., I mean in the night. You get what I mean? So, which means the exam will be open for more than 24 hours. Does that make sense to everyone? So you can decide to start at any time within the stipulated time, except that the moment you click, if you are not ready to start, don't start, because the moment you click on that, your time is going to be running out, and you only have 1 hour 30 minutes to spend on the exam. The exam has 24 questions. 22 questions are just multiple choice. In the multiple choice, you don't need to show your work. You just choose appropriate option. Then there's going to be two short answer. The two short, that requires that you're actually going to share work. So my TA on Friday, we walk you through some midterm one practice questions, and of course, I'm also going to upload the midterm one practice questions today. I need you to check, the Canvas. Like I said, the exam is going to be conducted between 6 p.m. on June 23rd to 11:59 p.m. on June 24. The exam is be open for more than 24 hours. Is there anyone want to ask question or need clarification on that? Go ahead. That's a very good question. Whether there's a public diagram, maybe as part of in the short answer, of course, I'm actually gonna anything can be asked, but this is what you can do. You can write, okay, and you can take a picture, right? Make sure that you can just upload that the way you upload the weekly assignment. Let me say the multiple choice, the moment upon submission, okay, you're actually going to receive your grade for multiple choice because that has already been programmed, but you're not going to receive grade for short answer. I said there are two short answer, right? The I think the multiple choice 22 questions of 33 point, the multiple choice are 66 points, why the short answer is 34 points. The two short answer altogether is 34 points. So um, if anyone involved diagram occur, you can use your pen, to draw, just take the picture. Then you're gonna upload that. There's gonna be a space, that I call file upload. I think I'm going to demonstrate that on Thursday to everyone. I don't know if I've answered your question. Okay, is there any other one want to ask question? Oh, those of you
Well,
online, I think you also get that information, right?
I got a
If you
question.
Okay, go ahead.
Will the exam cover chapter 3, or is it only chapter 2?
That's a very good question. Somebody asked online whether the exam will cover chapter 3. No, the exam will only cover what we did in week 1 and week 2. Whatever we're going to be doing this week will not be part of midterm 1. I don't know if I've answered your question. The person online,
Yeah,
have I
yeah,
answered your
yeah,
question? Oh,
yeah. You
okay.
answered my question.
So, so if I were you, the multiple choice, we spread around the cardinality, the potential product, the set, everything that we've done, like using a common sense, what is it, this, than that. Like I said on Friday, my TA is basically going to walk you through practice questions. Like I said, the exam will be uploaded. In fact, the exam has already been uploaded, but you can't have access now until 6 p.m. on on Friday, June 23rd, and I'm actually going to leave it open for more than 24 hours. Okay, the latest submission is going to be 11:59 p.m. on June 24th. But when you click on start, you can only spend 90 minutes on this exam, because the moment you click on start, it's going to be your time is going to be running out. Okay, you can start at any time within the window. Okay, okay, that is the information. If you can read detail on the course on the announcement section. Uh, like I said today, what we're going to be doing this week is not going to be part of midterm 1. Like I said, it's only what we did in week 1 and week 2. Now we want to start with 3. This is week 3, and of course we're going into chapter 3. We call that discrete random variables and their probability distributions. I want to welcome you to this chapter, and of course I'm going to, in the outline, I'm going to walk you through what we call discrete random variables. Then we're going to talk about expectation, variance, and standard deviation of discrete random variables. Then I'm also going to talk about linear combination of random variables. Okay, so I need you to pay attention to what we're going to be doing. Okay, now let's start with the random variable. If you take a look at what I'm displaying now, I told you the other time, we live in a stochastic environment. We live in a probability space. And what makes the world to be probabilistic is because of the fact that things changes. And when we talk about variable, of course, a variable is anything that is liable to change. Okay, it could be blood pressure, it could be your grade, it could be inflation rate, employment rate, and so on like that. Of course, situation where you actually have different kinds of measurement, even using the same data generating process. Now, but we want to focus on random variable, not just variable. And what do we mean by random variable, for God's sake? When I talk about random variable, we believe that when we perform experiments, there's something in our mind. Experiment does not necessarily mean I need to be in my physics lab. Does not necessarily mean I need to be in my biological lab, because life itself is an experiment. Because whatever we do, will lead to outcome. Okay, I told you the other time, uh, when we don't just perform experiment, but in a stochastic world, we perform random experiment. The random experiment, of course, is when you actually have outcome that are not the same. Like it leads to different outcome when you do that, which means you don't get one outcome, you don't get the same outcome when you perform the experiment repeatedly. Just like uh, you can what happened yesterday. I didn't even know that was a holiday. I just came into the building. I was not able to get access to the building. That is part of the stochastic world. And I'll check online and I realize that, oh my God, so there's another day today. Okay. That's part of what we face in the world. That is what made the world stochastic. Now, when I have different outcome, that is a random experiment. But before we go into experiment, we got something in our mind. I want to believe I'm able to be a businessman before I go into business. There's something in my mind. What do you think I have in my mind? I want to make profits. That's what I have in my mind. But you know what? When you take a look at the sample space of possibility, there is event of making profit. There's also event of making loss. Okay? I just wanted to take note of that. Now, when we really want to understand our environment, when I say understanding our environment, like I want to understand my political environment, economic environment, social environment. If I want to understand my environment in general, because the environment is probabilistic, then I need to be able to understand probability. And how can I understand probability? I need to first understand possibility, the possible events that can occur in my environment, and which we call the sample space. But let me tell you this. When we assign numerical values to elements in the sample space, just like a businessman or woman, in his or her sample space, there's profit, there's loss. If we now want to assign values, figures to that, that becomes a random variable. A random variable is assigning a numerical values to elements in the sample space. On average, how much can I make on profit? On average, if I lose, how much am I likely going to lose? If you're talking in terms of figures now, in terms of numbers, okay, you assign that to possibility. That's what I mean. Then we have what we call a random variable. Now, a random variable can be discrete, can be continuous. A random variable is discrete if it can be expressed as whole numbers, like it can be counted, like the number of students in this class, the numbers of cars sold last month by a dealer. That's a discrete random variable. And let me tell you this: the numbers of cars sold, every month by dealer varies. What is sold in January is different from what the number that is sold in January is different from the number that is sold in February. Okay, that's what makes it a random variable. But you know what we're going to do here? We're actually going to denote our random variable with an uppercase letter Y. I can use X, I can use Y, but whatever um, you know letter I'm actually going to use, I need to I'll define that. So that's what we mean by a discrete random variable. Now let me tell you this. In a stochastic world, when you have a random variable must have its corresponding probability. I'm going to say that again. Every random variable has its corresponding probability. Take a look at this. The probability distribution for a discrete random variable, which means what do I want to talk about here? We want to believe that when I talk about random variable, okay, it can assume values, which we actually maybe we're going to know the range. Oh, from the smallest to the largest, the support of that. You know what I call a state space, okay, of that. Okay. Now, let me tell you this. uh, if I have different values, some values they have a greater chance of occurring than others, and that's what you're going to call frequency, which is the frequency of occurrence now is the probability of that particular outcome. When we talk about the probability of an outcome, you know what we mean? We're actually talking about what is the numbers of times that particular value occur. I'm performing experiment now using equipment, probably in engineering, and I'm using this. Maybe I'm reading. I look at the values. I actually write it down. Okay, I do it again. I write the value down. Of course, maybe we get some 5.1, 5.1, 5.8, 5.9, and I want to know how many times does 5.1 occur? How many times does 5.3 occur in my repeated trial? It's just like somebody doing business. Oh, I've done a lot of businesses. How many times do I record profits? How many times do I record loss? Now we're looking at the frequency of the profit, the frequency of the loss that we're talking about, the probability. So the probability is more or less talking about the chance of the occurrence of a particular event, which is basically going to say the numbers of time that particular outcome repeat itself. If that very outcome repeat itself more often than others, then the probability of that event occurring is very, very high. That is very likely. That's what we mean. When you see a weather report that, okay, maybe tomorrow, like yesterday, I already know what the average temperature for today is going to be. I saw 90 for my county, Anoka County. I saw 90. How did they arrive at 90 degree? They arrive at 90 degree because they look at what has happened in the past. Okay, out of 100 days that is going to look like today, okay, 90% of a time before they can actually say there's going to be 90% chance of this, 90% chance of that. It means out of 100 of the similar days in the past, 90 days out of 100 will exhibit that gesture. That's exactly what it means. Now, take a look at that. When I have a y, if a random variable y, there's going to be a corresponding probability associated with that. When I succeed, the probability of succeeding is more than the probability of not succeeding. That's what it means. Okay, when we're talking about discrete probability now, we're talking about a function, a mathematical function that will enable us to describe the possible values a random variable can take and with their corresponding probability. And that's what you see as the probability of. I wanted to take a look at this now. The probability of an uppercase y equal to a lowercase y. When I started the other time, an uppercase y, right? That's a random variable. But the lowercase y is a realized value, like a particular value that random variable can take. So please take note of that. I'm going to go into an example now. A supervisor in a manufacturing plant has 3 men and 3 women working for him. He want to choose 2 workers for a special job. Okay, let me tell you, the problem in the world actually start from one of the problem in the world is selection. Okay, we want to choose. Okay, we got more than they want to choose 2 here, but they got more than 2 people to choose from. The question now is, what strategy are we going to use in choosing 2 in such a way that it will benefit our company? Okay, now um, not wishing to show any biases in his selection. Okay, he decided to select 2 workers at random. Let Y, please pay attention now. Let Y denote the number of women in his selection. Now take a look at this. He has not selected. But before this selection, we have certain thing in mind. What you have in mind is your random variable. Now, what he has in mind is now, okay, how many women will be selected? That is what he has in mind. Okay, and that's why we determine, he said, let Y denote the number of women in selection. I find the probability distribution for Y. Every random variable has a corresponding probability distribution. Okay, now if we want to work this out, you now need to figure out possibility first. I told you, when you want to solve problem in probability, you need to first decide on your sample space. Of course, your sample. Don't forget. Does it really make sense if I want to compute probability and I don't know sample space? You remember the other time, the probability is the ratio of the required outcome to the possible outcome. The possible outcome is the sample space. Without the sample space, you cannot efficiently compute probability. And now there are six people to choose from. Okay, we got six people to choose from. Okay, and we basically want to choose two. Okay, if I want to know the possibility, okay, I need to be able to recall what you've done before. What you've done before you actually qualify to be in this class is how, if I want to choose two out of six, what mathematical technique am I going to use? That's combination. Okay, I don't know whether you've heard about combination. Has anybody heard about combination? Okay, now if I want to choose two out of six, it's basically going to be six combination two. Okay, six combination two. Okay, the six combination two is going to be 6 factorial divided by 6 minus 2 factorial, 2 factorial. So 6 factorial, 4 factorial, this is going to be 15. Okay, so which means the possible number of ways is basically going to be 15. Now this 15 now is the cardinality of the sample space. The cardinality of the sample space. This is more or less like the possible ways of choosing two out of six. Possible numbers of ways of choosing two out of six. But you know what? In the end, you know what is going to happen? It's only one way that will happen, because the manager is just going to choose once. You get what I mean? Now, if you take a look at what I displayed, the manager did not want to be biased. How do I know? Go back to the question. I needed to take a look at the question. It said, not wishing to show any biases. Oh, not wishing to show any biases, that it's me, this guy, want to give equal chance to 15 ways. Equal chance to 15 ways is basically going to be 1 out of 15. Does that make sense? That was why I actually call the probability of EI to be 1 over 15. Okay, so, and that was why I said S contains 15 sample points. If S contains 16 sample points, of course, the cardinality of the sample space is 15. Okay, and of course, we want to assume to be equally likely because the random sampling was employed. When the random sampling is employed, when do I use random sampling? When I want to choose from people and I want to apply equal chance, no favoritism, no biasedness in the selection, and that is why it's going to be 1 out of 15. And of course, when I say the probability of AI equal to 1 over 15, it actually means I start from 1 to 15. which means the probability of E1 equal to probability of E2 equal to until you get to probability of E15, which is 1 over 15. That's exactly what we mean. That's exactly what we mean. Each of the ways now become event. That's what it means. Now, in that situation, we said the values of y that have non-zero probability are 0, 1, 2. Now take a look at this. We're talking about the numbers of women in the selection. Okay. Now the numbers of women, don't forget we want to choose just 2 out of 6. And uh, if y we denote the numbers of women, then there's possibility. You got to consider the possibility in your selection. There's possibility you don't choose any women at all. There's possibility you're going to choose one woman. There's possibility the 2 people you choose, but they are women. There's a possibility. Now 0, 1, 2. That is the state space. Now that's what we call it. We call this guy state space. State space of y, or you call it support of y. State space of y, that's talking about the possible values the random variable can take. The possible value it can take now is going to be from 0 to 2. Don't forget y here actually represent the numbers of women that can be selected. Does that really make sense now, right? Okay, now do you know there could be a lot of questions here? If I ask you to find this, what do I mean? Find the probability of y equal to 0. The probability of y equal to 0 now means what is a probability that no woman will be selected out of the 2? When I say what is the probability, we're just trying to say what is the frequency? Frequency, we actually mean frequency. That's what we mean. The frequency is like what is the number of times that can be possible. That's exactly what we mean. Now the question now is, we're told at the beginning that we got 3 men and 3 women. Okay. Now men, women, right? What is the population of men? 3. What is the population of women? 3. Okay. Now, what is the probability of choosing 0 if 0 women? Okay. If I choose 0 women, it means I want to choose 0 from 3 women. Okay. And if I choose 0 from 3 women, automatically, I will choose 2 from men, or the 2 from men. And this is going to be divided by possibility. What is the possibility? Which is choosing 2 out of 6. You know what we've done now? This is more or less like a probability, okay, way of figuring that guy out. And you know what? If I can use that to find what is the probability of y1. So if this is y equal to 0, I can also find y equal to 1, y equal to 2. You know what I'm driving at? What I'm actually driving at is I want to generate a probability distribution for the possible values of the outcome variable. So the probability of y equal to 1 is good. Don't forget, I got men, I got women. Okay, this is 3. Okay, for those of you that may not know, this is another way to write this. You can decide to do this. Okay, you can, if you don't want to write it that way, you can do this. Okay, and I'm talking about combination. Okay, so take a look at that's another way to write it. Okay, so 3 combination 1, and this combination, because you're choosing 1. Okay, and this divided by 6 combination 2. So when we do that, that will give us 3 over 5. Okay, for this one, this give 1 out of 5. Okay, and for the last one, this is how far we can go. Okay, like choosing all the 2 from women. Okay, 0, 3 combination 2 divided by 6 combination 2, and this actually give us 1 out of 5. Okay, so 1 out of 5, 3 out of 5, and 1 out of 5. Now, when you take a look at what we have now, do you know we've succeeded in generating probability distribution? When I say probability distribution, I basically want to know what are the possible values a random variable can take with their corresponding probability. Now, when the random variable equal to 0, the probability was 1 over 5. When the random variable equal to 1, the probability was 3 over 5. When the random variable equal to 2, the probability is that, oh my God, I can show that by table. That is exactly what I've gotten now. That is what we mean by probability distribution. So by probability distribution, you basically want to know what is the possible values a random variable can take with their corresponding probability. You know what we're trying to tell the world. The possible value the random variable can take is from 0 to 2. And the corresponding probability are what is given there. If you really want to know whether you are right, when you add up the probability, it should give you 1. Does that make sense? Like 1 over 5 plus 3 over 5 plus 1 over 5, it should give you 1. If it doesn't give you 1, then you have not considered the whole sample space. Does that make sense? It shouldn't be more than 1. It shouldn't be less than 1. It should be exactly 1 when you add them up. Now, the next thing we want to do now. I want to look at it from the graphical angle, because some of you may be wondering. I know some of you, you've heard about histogram, and you're going to be wondering, where does histogram come from? Because we actually use histogram if we basically want to know what is the distribution, like, is it normal or not? Now, this is the way histogram comes. You know what you're going to do with the histogram? You're basically going to plot. What you're going to see in the y-axis, in the s-axis, in the horizontal axis will be the values of the random variable. You can see 0, 1, 2, right? And what you're going to see in the vertical is going to be the probability. Now, take a look at this graph now. What you have in the table is what was plotted. Therefore, we refer to this as an histogram. The histogram is a graphical way to investigate the probability distribution of data set. So that's what you can see now. Now, I want to go into a probability model. Of course, a probability model describes the possible outcome of a chance process and the likelihood that those outcomes will occur. We can go into an experiment. Consider a fair coin that you toss 3 times. You toss a coin 3 times. But you don't just toss this coin 3 times, there's something in your mind. Well, before you go into research, we can never take an empty mind to the research. There's always something in our mind in terms of favorable outcome. And what do we have in mind? Numbers of heads. That's all we have in mind. And don't forget, the coin is actually having more than one side. We have a head and tail. Now, here you can say I'm using X. Initially, I was using Y. It doesn't matter. Okay. Now, provided I define that, you can say I define my X. Now, when you choose, coin 3 times, okay, those are the possible events. There's possibility that the 3 times that you chose that, you could add tail. If you want to use the idea of tree diagram, okay, for you to know if that is toast, if a coin is toast 3 times, okay, I'm going to show you right away. Because what of in exam, not in midterm 1, what of in midterm 2, and I ask you to toast it 4 times, and I ask you what is your sample space, and what is the probability distribution. Now, you know what I want to do now? I have an experiment, and I know my random variable, and I ask you to figure out what the probability distribution is. Okay. Now, a coin is tossed three times. When it is tossed once, when I toss a coin once, there are two possibilities: head, tail. That's what you're going to have in your sample space when it is tossed once. But when you toss it twice, this is going to go to head, tail. This is going to go to head, tail. Now let's see how many possibilities we're going to have now. Head, 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 tail, head, tail, making four possibilities. If I now toss it three times, I'm going to continue to go head, tail, head, tail, head, tail, head, tail. Take a look at that. There's going to be eight possibility. Now I'm going to have head, tail, tail, head, and tail. There's going to be eight possibility. Okay. Now the eight possibility is what we are seeing now. But you know what? Before performing this experiment, I've already defined my random variable x to be the numbers of head. Now, the numbers of head I can have now, we're going to go from 0 to 3. Instead, I see 0 head. I see 0 head in a situation where I got tail, tail, tail. Does that make sense to everyone? Okay. Is there anyone struggling with the way I talk this morning? When I'm looking at faces, are you sure you understand the way I talk, right? If you are struggling with the way I talk, please let me know. Okay, now, do you now see the random variable now, right? X, 0, 1, 2, 3. What is the next thing to do? The next thing now is, are you surprised with that table? I've generated probability distribution from the experiment. Now, the value now, 0, 1, 2, 3. What is the probability? It's just like, how many times do I have 0? How many times do I have 0 is the tail, which is going to be one time out of 8. That's why you see 1 over 8. How many times do I have one head? Oh, one head. Look at that. One head, maybe a state tail head, tail, or tail head. That's one head. Now you can see that now. So what I have in the table now is what we call probability distribution. Okay, and that is a corresponding histogram, which means if I generate my probability distribution, histogram will be very easy to construct. Okay, that's what you see now. Okay, now a random variable takes numerical values that describe the outcome of some chance process. The probability distribution of random variable gives its possible values. It gives its possible values and their corresponding probability. Does that make sense? Okay, now you already know. Now the question now is, why am I generating probability distribution? Oh, I'm generating probability distribution because I needed to calculate average. You see that? We need to get an average. We want to figure out in a stochastic world where things changes rapidly, we are interested in a particular data point that will represent the rest. And that is what we're going to be called center, which we mean average. Okay? So what I'm going to do is, how do I, what do I mean by what is the meaning of average? When we talk about expectation, and when we talk about what probability will enable us to do, I'm actually going to write that for you to be able to see. The probability depicts, okay, probability distribution, depicts, okay, depicts the expected outcome, okay, of expected outcome of a random variable, okay, from a given data generating process. Situation where you have different values and with the corresponding probability, okay, what you're going to be looking for is the average. Average is what we call the expectation. What is the expected value of my outcome? It's more or less like those in investment. They basically want to know, what is going to be the expected return, particularly in stock that changes over time. Okay, and it will also help us to edge out the risk. Okay, I'm still coming back to that. Edging out the risk. So now, if you take a look, I have values, I have probability. Of course, I know they must sum up to 1, and the probability has to be between 0 and 1. Now the question now, how do I find the expectation? How do I find the mean? If I want to find the mean, what I'm just going to do is to multiply the value of a random variable by its corresponding probability, and I'm going to add them up. That's what I'm doing now. That's what we call expected value of x. This is how your CGPA is computed. You offer subjects in this university that are not of the same credits. Does that make sense? They are not of the same credit, mean they don't have the same weight. What is acting as weight here is the probability, which is the numbers of time a particular outcome occur. Okay, that's exactly what we mean. So if I want to figure out the average, what I'm just going to do is just to multiply the random variable value by its corresponding probability. I'm just going to sum it up. I'm going to give you an example now. This is an example. A baby's Abga score is the sum of the rating on each of 5 scales, which give a whole number from 0 to 10. You can see they've defined X. What is X? Always watch out for that, the definition of your random variable. Does that make sense? Okay, now it is Apgar score of a randomly selected newborn, and which is going to go from 0 to 10. Going from 0 to 10, that is the support of X. That's what we call the state space. And you've been given the probability. You know the meaning of this? The meaning of this is like, if you look at that 0.001, you know what that means? 1 out of 1,000 times. 1 out of 1,000 times they've had a baby with a score of 0. That's what it means. Okay, please take note. Read meaning to that. Now compute the mean of the random variable in a stochastic world. We normally look for average, because the data varies. How can we get a data point that will represent the rest? That's exactly what we mean. So what are you going to do now? You just multiply them out. See that? I got the result of it, 8.128. So what I'm going to say now, the mean Apgar score of a randomly selected newborn is 8.128. And this is the average Apgar score of many and many randomly chosen babies. Take a look at that. That's an average. We've taken into consideration the values the Apgar can be with their corresponding probability. We've already put that into play. Okay, take a look at that. Now, how do I tell the reliability of 8.128? I choose this guy to represent this consistency, right? Oh, go and represent us. How am I going to know this guy is really representing them? This guy is like an average. If I want to know whether it's representing them, I need to know how far apart is this guy from the respective observation. How far apart on average? Is it somebody who normally visit them regularly to hear from them? You are representing me. You need to be closer to me. If you are not closer to me, then there's no way you're going to represent my view. Does that make sense? And if I want to do that, then I'm basically going to be looking for standard deviation. Initially, what we're looking for is variance, but there's no way to get to variance without passing through standard deviation. The standard deviation and variance, they do the same thing, except that in statistical analysis, we prefer standard deviation. You know why? Because standard deviation has the same unit as the mean. But variance is measured in square units. Square units. Variance is measured in square units. Okay, and that's why we only we reckon more with the standard deviation. Now, if I want to get like I said, before I can get the standard deviation, I need to first get the variance. After getting the variance, then I'm going to find the square root of this of the variance to give standard deviation. Where am I taking the square root? Oh, it has a square unit before. When I take the square root of that square unit will go away. And it's basically going to have the same unit as the mean. Makes sense now? This is theory of statistics where we need to tell you what happened behind the scene. Okay, now if I want to find the variance now, you need to be subtracting the mean that we got the other time from the respective observation. You can see you are looking at the difference, right? That is the distance that I talk about. Distance that I talk about. That's why we're looking at the difference, right? X1 minus mu x, then you square that. Why am I squaring that? I'm squaring that because I don't want negative. I want to work with positive. Now, that's what I have. Then when you now take the square root of whatever you get, that becomes the standard deviation. Okay, so this is how you get the variance first. You take the square root of the variance, and that will give you the standard deviation. Okay, the standard deviation is actually going to tell us how reliable is the mean. The more the standard deviation, okay, like in investment, the more the standard deviation, the more the risk. If I want to measure the risk of investment, we look at the standard deviation. It's not just the expected returns, okay, only. Okay, so take a look at that. That's how that is computed. Okay. And the most important thing is to look at the interpretation. A randomly selected baby Apgar score will typically differ from the mean about 1.4 units. That 1.4 units is the standard deviation. When you are getting the mean is not an exact result. The formula that leads to getting the mean is a model. I told you the other time. We want to use a model to capture reality, but model cannot give us exact reality. And that is the reason why there's going to be a deviation. We actually want to get the amount of deviation. That's what you see. Okay, so the next thing is just to look at time. We could have a linear combination. Okay, we are x1, x2 up to xn. They are random variables on their own. And we have a y. There's also random variables. It's a linear combination of that. The a1 up to an, they are just constants. Okay, and we can prove some theorem where the expected value of as plus b or as minus b, expectation is the mean. Expectation will attract a random variable x. That's why you say expected value of x. Take a look at that. And the expectation of a constant is a constant. If I put $5 in my pocket, provided no external force acts on it, in the next 20 years, I'm still going to see $5 in my pocket. I said, provided no external force acts on it. You get what I mean? It's going to be there forever. That's exactly what I mean. Now, we want to talk about the mean of a random variable. Take a look at this. Initially, you were given that we've done today. Random variable values with their corresponding probability. And they asked you to find they wanted to find the expected value of g of s. The g of s is a random variable now, but it is x minus 1 all squared. It's like a random variable depending on another random variable. You know what you're going to do? You actually going to, you want to find the expected value of x minus 1 squared. It's going to be summation x, whatever function you are given f of x. Then you start plugging in the values, and that will actually give what you see right now. Take a look at that. That will give you what you see right now. I think I put some corollary that you can just read about the linearity of expectation, the variance, and so on like that you can just read. But you know what? I don't want to rush you. I think I'm going to start from here. Okay. If you take a look at this now, you have been given the expectation, you've been given the variance, and they are now asking what is the expected value of 3x plus 7? What is the variance of that? I think I'm going to start from here because my time is up. I'm going to start from here tomorrow. Like I said before I go, um, the exam has already been uploaded, except that you are not going to have access until 6 p.m. We are not going to have access on the 6 p.m. of June 23rd. The exam is going to go from 6 p.m. June 23rd to 11:59 p.m. June 24th. So which means the exam is going to be left open for 24 hours, more than 24 hours, but you can only spend 90 minutes on that exam. You can start at any time. The moment you click on start, your time is going to be running out. After 90 minutes, you may be logged out or not. But even though I also then for those of you who have accommodation letter, please send them to me because those who have accommodation letter we have extended their time. Don't spend more than the time that you are supposed to spend in that exam. There's going to be 22 multiple choice question and 2 short answer. You do not need to explain in the multiple choice. Just pick the right answer in the multiple choice. But in the short answer, of course, you're going to show your work and you're going to upload a file. You can write, okay? You can write and take a picture. Make sure you write clearly, okay? And you're going to receive, what is it called? Upon the submission, you're basically going to have your result for multiple choice only, okay. You're going to have result for multiple choice only, and after some time that will be updated, with the score that you have for the short answer. And I want to say again, it will cover what you did in week 1 and week 2 only. Whatever we are doing now in this week will not feature in midterm 1. And I've also uploaded solution. Even though your assignment has not been graded, my TA will start grading that. But I've already uploaded the solution to assignment 1. So the exam is going to cover everything that you've done: cardinality, Cartesian product, complement of a set, De Morgan's theorem, uh, symmetric difference, probability. Week 1, week 2, with when you review that, you're basically going to have 100% for that exam. So this way, I'm actually going to stop today. Make sure you stay safe and have a lovely day. Bye for now, everyone. Sophie online. Is there any question? Sophie online.
No,
Is
thank
there
you.
any question? Okay, so we should make sure you guys are good. Make sure you stay safe and have a lovely day. Bye for now, everyone.